So good morning again. My name is Thomas Graf. I'm CTO and co-founder of Isovalent, but you may know me better as one of the creators of the Cilium project. And this morning, I would like to introduce you to something brand new that we have worked on furiously over the last couple of years, which is called Cilium Mesh. And it is an exciting new way to connect Kubernetes, the new world of Kubernetes, with the legacy world that we all like so much. So what this talk is about, and what I want to introduce you, is how can we make Kubernetes, what we see on the right, which is abstracted with services and applications, and we have high-level intent-based policy and all of this. How can we make that work? How can we connect that to the old world of data centers with MTLS and BGP and only IP addresses, and part is VMware, part is Cisco, some servers standing around that nobody knows what they even do. How do we connect these two worlds together? For those who have never heard about Cilium and what this is a very quick introduction into what is Cilium, because that is the foundation of what we have built with Cilium Mesh. So Cilium is a CNCF project. We originally created Cilium, then founded Isovalent a year later around it because there was so much success with it. And then a couple of years later donated it to the CNCF. So it is now a CNCF governed project. It started out as a CNI, a container networking interface implementation, so the implementation that provides networking for containers, Kubernetes, Nomad, Docker, all of these container orchestration systems. Today it is much more. So today Cilium is an ecosystem of different projects consisting of Cilium the CNI, Cilium Service Mesh, Hubble for observability, and Tetragon for runtime enforcement and runtime observability from a security standpoint. What connects all of them together is the use of eBPF, a super powerful technology in the Linux kernel that allows us to do things very effectively, very efficiently, high performance, and with a lot of control and observability. And as we will dive a bit further into Cilium Mesh and Cilium, you will see how eBPF enables us to do things in brand new ways, which are really exciting, not just for engineers, but also for end users. So essentially, Cilium, originally created by Isovalent, now a CNCF project, provides networking, observability, security, service mesh, and ingress. And this is the whole kind of stack that we provide today. So starting out with the networking layer at the bottom, you can see we have lots of functionality, network policy implementation, layer 3, layer 4, layer 7. We understand HTTP, gRPC, and so on. We have DNS-based policy. We have a whole bucket of encryption, IPsec, WireGuard with the newer version, MTLS-based mutual authentication, load balancing, a whole fleet of networking, IPv4, IPv6. We can do extensive load balancing. Overlays, we can do BGP, SRv6, and so on. On top of that is the Hubble observability layer. We'll see a couple of examples because we bring all of that to the Cilium Mesh as well. And then on the top layer, the service mesh, which provides ingress, authentication, traffic management, and so on. And then you see on the right, we can run this completely independently from everything else. Tetragon, which is very similar to Falco, provides runtime security as well. Of course, everything we do with Cilium is completely agnostic of the underlying infrastructure. It's very obvious. If you are a Kubernetes native person, that's very obvious. But I think it's worth saying that it does not matter whether the infrastructure is a cloud, public cloud infrastructure, whether it's your own private cloud, whether this is on-prem, whether this is a virtual machine, or what type of Kubernetes environment, it runs everywhere. But let's dive in a little bit. So what was the promise, what was the idea, the vision, why we even started to work on Cilium Mesh? We have a lot of customers that are effectively running Cilium in Kubernetes environments, and they have built entire new infrastructures running at tremendous scale. One example is OpenAI is using Cilium to manage their level of scale. But we have customers like Palantir, massive scale. We have customers like Datadog running a massive SaaS. They've all used Cilium concepts to scale out a networking layer that scales well and is highly secure. Many of them have asked us, well, this is awesome. So we are very, very efficient. A few people can manage these giant Kubernetes environments. Why can't you bring that to the existing infrastructure we have where we are still running virtual machines and servers? Right? Can you bring all of these excellent high-level concepts, network policy, service abstraction, intent, controllers, resilience, all of that to existing worlds? And that is what Cilium Mesh is about. So Cilium Mesh is extending what we've built with Cilium so far, which is the Kubernetes networking layer, like controlling and managing network traffic across Kubernetes clusters, and we have been able to connect multiple clusters together so far, and introducing a brand new transit gateway. So a transit gateway is the ability to run Cilium as a router, as a gateway. So think about it as like a Cisco switch type appliance that you can deploy into an existing network. Both a physical network, so you could run it on a server, on a virtual machine in your data center, or as a virtual machine in a VPC, in a virtual private network that you have in your public cloud. And it will then be the gateway or the bridge that connects your old world with the new world of Kubernetes. Which means that, let's say you're running a fleet of EC2-based VMs, or you have a VMware data center where you're running VMs. You can connect those machines into the Kubernetes environment. And what's super exciting is that all of these machines and all of the handling and all of the control looks like Kubernetes. What does that mean? It means that we're actually running real Kubernetes, a real Kubernetes cluster. Let's say in this lower left corner where we're seeing an AWS environment, we're actually running a Kubernetes cluster. So you can use the Kubernetes API to see which VMs are actually running. So in the Kubernetes world, we have a concept of Kubernetes endpoint. So anything that's addressable from a network perspective is a Kubernetes endpoint, and you can run kube control, get endpoints, and you see all of them. If you're running the transit gateway, you see all of the endpoints like this. So all of the existing tooling that you have will just work in that environment as well. Or you're used to defining a network policy in a Kubernetes environment. So if you want to do firewalling, distributed firewalling, you're used to applying a Kubernetes network policy. What is allowed to talk to, who is allowed to talk to whom. In our environment, you do this against the Kubernetes cluster that represents that on-prem environment. And you can just apply a network policy. We're bringing all of these concepts, services, load balancing, network policy, observability, into your existing environments as well. And what's really fascinating is you can do all of this without actually modifying, running anything on those machines, right? These machines remain unmodified. You simply bring in the Cilium Transit Gateway as you would bring in a router or a gateway in a traditional network setting. This is not really a completely new concept, of course, right? We really see this as the natural evolution of how we've built Cilium. We initially built Cilium as a networking layer for one Kubernetes cluster only, right? The initial goal, the initial mission was we have multiple containers, they're running on different servers, how do we connect them together? That was the initial scope of Cilium 1.0. We then built cluster mesh or multi-cluster, where we now allowed multiple clusters, but all Kubernetes to be connected together. And now we're extending that further and allowing virtual machines and servers outside, which are not Kubernetes, which are not running containerized applications, bring them into the mesh as well. Some of you may say, well, that sounds very, very familiar because you may have been using cluster mesh, our multi-cluster concept. And you're right, it's exactly built on top of that. So all of the control plane components, all of like the tooling that we needed to make this work in order to propagate the state and build this like grand big control plane that sees everything and that can control everything, we already had that for our multi-cluster system. So this is not something completely new from scratch. We have extended what we call cluster mesh. This is a summary of how cluster mesh works. In this case, you have multiple Kubernetes clusters. They run independently of each other. They don't know each other. They're not aware of each other. They're not federated in any way. They're completely independent. And then we run Cilium in both clusters. And Cilium builds essentially a network plane below. That's what we see, all of the yellow bars at the bottom. Essentially spans a networking layer across all of these clusters. And it provides service mesh, of course, like traffic management, layer 7 load balancing, all of like modern service mesh functionalities that modern application teams want, but also service discovery. One service, one application running in one cluster can identify, can discover a service and application in another cluster by its DNS name. Of course, identity-aware network policy, so we can do network policy enforcement. We can define rules, who can talk to whom. Application A in cluster 1 can talk to application B in cluster 2, right? We have observability. We'll see a couple of examples. Encryption, so we can transparently encrypt all the data in transit across the clusters. And of course, a variety of different network topologies. Because most of you, if you want to deploy this, your network ops team will say, well, but how does this actually work? Well, will it speak BGP? Will it create a VXLAN overlay? Will it do MTLS? Like, how does this work in a VPC? And so on, all of these questions. We've already solved that with multi-cluster before. We do speak BGP. We can reprogram a VPC routing table in the cloud. We can create Geneva overlays, VXLAN overlays, all of this. Cilium was already capable of running in traditional enterprise networking environments for Kubernetes workloads. What we've added is the ability to run Cilium as a gateway, so you're not limited to just run Kubernetes with Cilium. This is an example of how Kubernetes provides service load balancing. Like, I'm assuming almost who is not running Kubernetes? Nobody. Everybody's running Kubernetes. Awesome. So this is super familiar to all of you, right? That was a tough question. Kubernetes uses service abstraction to define load balancing rules, right? We've all used this. We have applications running, pods running, and we use a Kubernetes service to abstract this to perform load balancing. In this case, cluster IP, which means that I have multiple pods running. How do I address all of these pods under a common name by a load balancing IP? Kubernetes services of type cluster IP. As I talk to this cluster IP, Kubernetes, or in this case Cilium, will automatically load balance to all of these pods. With Cilium Mesh, you can use standard Kubernetes services like this. In this case, it's the Cilium service, or it's actually the Kubernetes service resource, and we are simply adding annotations to mark that this service is global, that it should be load balanced across the entire mesh and not just within the scope of one single Kubernetes cluster. So your application teams don't have to change anything. All you have to do is annotate the service with one single line, and voila, your load balancing works across even traditional infrastructure. Of course, we're also bringing massive observability. Some of you may have seen the news we've published last year. We have entered an amazing partnership with Grafana Labs as a company. And as a result of that, because Isovalent is a group of kernel hackers, essentially, that's how we started out with. We haven't been traditionally good at providing dashboards. Now, as we have a partnership with Grafana, we've suddenly become very capable of building amazing dashboards. So we have dashboards for network observability. We can build golden signal dashboards. Yes, this is an example. Golden signal dashboards where we can see rate of HTTP errors. We can see the HTTP latency. We can correlate HTTP latency with the CPU load on the node, and so on. Right? This is a concept originally introduced by Google. Like, this is Google's way of monitoring applications or modern applications. The 4 golden signals. You can get this with Cilium, and of course now also with Cilium Mesh. As I talked about Kubernetes network policy, right? This is a standard Kubernetes network policy. We're all used to this. Defining a policy, pod A can talk to pod B. You can now use this standard Kubernetes network policy to define rules that your VM, let's say running in a VMware data center, can talk to a Kubernetes pod. How does that work? If you look at the policy a bit closer, we see in the red, Kubernetes network policy is essentially just metadata. It's allowing certain labels to talk to certain other labels. What we have done is allow you to define what labels should represent, let's say, a VM running in a VMware data center or an EC2 instance running in an AWS VPC. And if it is running in AWS VPC, we automatically extract the tags of the VM. So if your EC2 instance has tags or labels, we take them out, we attach them to the endpoint, so you can essentially match on EC2 labels in Kubernetes network policy. So you can use existing tooling, you can use your existing workflows, maybe you're using GitOps to define network policies. You can continue using all of that, but now actually also address your existing infrastructure. This is Hubble UI with the service map, used by lots and lots of teams. It gives you an overview of all the services that are running, like how are they connected with each other. Do we see traffic that is being dropped? Do we see HTTP errors being returned? Are there network policy errors? All of this you can see in one UI. This is now also spanning to your legacy infrastructure, and you can see VMs and servers on this as well, and not just their IPs, because we are, as I said, we're allowing you to define labels to describe what is actually your VM. Those labels is what you will see here. Right? So you get a Kubernetes-like experience for your existing infrastructure as well. And with that, I think we have a ton of time for questions because we started a little bit early. Happy to take any questions, but first, thank you very much.
Any questions? So as you can see, if you will have questions, please talk closely to the cube, which I will throw to you, or even Andy will throw to you, because I will miss everybody. Who has a question? Don't be shy.
The question over here. Oh.
I actually did. Yeah, so I was wondering about the transition path. Let's say you have a legacy Kubernetes cluster and you're running a different CNI. Is it a requirement that you need the Cilium CNI underpinning all of this to provide the abstract network layer that runs across all the clusters, or can is there a pathway in being able to, for migration, where you can have a hybrid situation with multiple CNIs?
I love the question. It's already a very practical question. How can I start using this? So yes, you can run on top of an existing CNI and even then get Cilium Mesh functionality. For example, you're using the CNI of one of the cloud providers. Let's say you're using the AWS VPC CNI, or you're using OpenShift SDN. Then yes, you can run Cilium on top of that in what's called CNI chaining mode. We do not support all of the CNIs though. So there's a list of well-supported and tested CNIs that we actually test with, but for the common and for the popular CNIs, this is possible. Sometimes some of the functionality is not available in chaining mode if the underlying CNI does not allow us to do what we need to do. For example, some of the layer 7 observability is not available if we chain on top of Calico, as an example. So sometimes there's specific functionality that's ironed out, but from an overall Cilium Mesh and using that to bring your existing infrastructure in, that is very decoupled from how the local CNI works. So that is actually something that is very, very compatible.
Can I have a bonus question?
Yes.
Typically, if I needed SRIOV support, I'd run Multus along the CNI. Is that still possible with this?
That is also still possible, and I even have more exciting news for you. We're actually building Multus into Cilium right now. So we're in the process of building Multus functionality where you can have multiple interfaces, multiple IP addresses, natively managed by Cilium. But you can also continue running Multus as you have before. With the support of essentially embedded or built-in Multus, you get the functionality that you can have network policy, observability, load balancing on all the interfaces and not just on the primary one. So even if you have, let's say, a high-performance SRIOV type use case and you use Multus, you can actually get observability on the secondary interface as well.
Thank you.
Another question here. Hey!
You showed us a Kubernetes service that is spanned across several clusters.
Yeah.
I was just wondering, how does this integrate with the DNS layer? Or
excellent,
what's the DNS name that this service would receive?
Great question. So you're essentially asking how does service discovery work? Like how do I discover a service in another cluster? So Cilium Cluster Mesh, and this also applies to Cilium Mesh, essentially uses standard Kubernetes DNS, which means you define a Kubernetes service so let's actually use this example. I'm creating a Kubernetes service in this cluster, right? Standard one. Kubernetes automatically creates a DNS name for this. So let's say that service foo, which means the service foo can be discovered in that local cluster. Cilium Cluster Mesh then requires you to create the same service name in the other cluster and then add this annotation. So I think this annotation, the global service. And as you add this annotation, it will logically create these two services together. So service foo in cluster 1 and service foo in cluster 2, which means as you look up service foo in cluster 1, you can actually then reach endpoints in cluster 2. So it uses the standard Kubernetes discovery, standard Kubernetes DNS, which means no changes to the application at all. You can even choose, let's say, create a service in cluster 1 which has no local endpoints. It only has endpoints in cluster 2. And that's how you can create a service that always is represented by workloads on the other side. That's what we mean with this Kubernetes native experience. We're not changing anything. All of the existing tooling continues to function. Does that make sense?
Yes, thanks.
Do we have more questions? Yes, another question over there.
Hi, good morning. Thanks for the talk. You said to connect to a legacy infrastructure part, you just need to deploy the transit gateway and don't touch the existing infrastructure. Can you also establish encryption with applications in the existing infrastructure without touching them, together with some services and applications running in Kubernetes? So can you establish an MTLS?
Yes, awesome. So I love every question is better than the previous one. So let's say we have a bunch of VMs running here, right? What we can do, so we will, let's say it's an on-prem setting, we're actually using BGP to integrate these VMs, so we will attract traffic from these VMs, right? There's no change on the VMs, and we will start advertising routes like to pods or VPCs on this transit gateway here. What we can do is we can do MTLS-based mutual authentication or encryption with IPsec and WireGuard from this point to anywhere in the mesh. What we're not touching is this line, right, from the original machine, because we're not changing anything on that machine. So this small path here, that's still probably within your data center or within the VPC, that remains unauthenticated, unencrypted, and so on. But as soon as it hits the transit gateway, we can do mutual authentication, network policy, encryption, firewalling, all of it.
Against the gateway.
It's against the gateway. And if this is running in a VPC, then we are reprogramming the VPC routing table to attract the traffic. Then we're not running BGP, of course. So we're essentially adding routes to the VPC routing table. Does that make sense?
Yeah, thanks. Thanks.
Yeah. It's like, oh, come on. We need a multi-hop, yeah.
Well, thanks for the talk. Good morning.
Well,
I have a question. How do you propagate metadata across multiple unaware of each other Kubernetes cluster? Do you run an own etcd somewhere in between, or?
Awesome. Yeah. So the questions are still getting better. I like it. So yes, we kind of. So what we do is we are actually running an etcd, but we're not storing the data persistently in there. And I will tell you what that means. So we're actually using each Kubernetes cluster stays as is, and we're using Kubernetes CRDs to store the state policies, services for that specific cluster, right? But Kubernetes CRDs and Kubernetes control plane has certain scalability limitations. So we're actually using etcd, our own etcd, then span out and propagate all of the state. But this etcd is stateless, which means you can actually restart it every 2 minutes. It's only used to very efficiently propagate all the information, what services are available where. So the actual Kubernetes control plane via custom resources is the source of truth, contains all of the information that matters. So you can actually wipe your entire Kubernetes cluster, kill all the workloads. As long as the API server and the etcd backing it stays intact, Cilium Mesh will also recover. Does that make sense? Yep. So we're not actually have our own control plane with state. It's all in Kubernetes. So as we run this mode, there's actually a Kubernetes cluster running here that we manage. So because there is no Kubernetes there, and we're also storing it in Kubernetes. And the only requirement we have is that the etcd backing this does not get wiped. Does that make sense?
Thank you very much.
Thank you. Is there another question from the middle? Maybe will be a bit easier. We still have time since we started a little bit early. One again on the other side. Perfect.
Okay, now I hope the questions will not degrade with me. What's the biggest number of nodes and clusters you tested Cilium with?
This is such a common question. It's awesome. And it's still getting better. I can now talk about scale. So number of pods, number of endpoints is about 300,000 that we've tested with. Number of nodes, I think 20 to 30,000 total. But I can tell you that's not the hard part. So the hard part is not like the total static scale. Let's say if you're adding 20,000 nodes over time, and then it stays at this size, that's never a problem. Everything that's built, and even for Kubernetes itself, that's not really a problem. The problem is usually like what we call churn. Like how many nodes are you introducing or removing over what period of time? So for example, one use case that we struggled with over a period of time where we had to improve scale was a user was running primarily batch jobs at the top of the hour and had auto-scaling enabled. So 50,000 batch jobs coming in, starting at exactly the same second, needing 500 more nodes, all coming in within 1 minute. That is like the explosion that was hard. So it's the churn. So it's how many pods are you scheduling or adding and removing over time? Do you have like 100,000 policy changes per minute? These are like the numbers that matter, because that's information that you have to distribute across the entire system, across all of those 20,000 nodes. And that's why we're using etcd, because that's using protobuf in gRPC, which allows us in binary format to very efficiently propagate information as needed. And it really gets down to calculating how many single-digit bytes of information do we have to propagate to all other nodes when, let's say, a new pod comes up. Right? So we're literally counting bytes there to be as effective and efficient as possible. So it's really the churn that matters, and not necessarily the total size of the infrastructure. So as far as like infrastructure, virtual machines and servers, that is typically very, very static. So we have no concerns whatsoever on the scalability side there. Did that answer your question?
Absolutely.
Cool. The last question up there. In the middle.
Yeah, I try to downgrade the questions. You mentioned BPF technologies that you are using there. Yeah, sometimes for some services, we're using some external provider or CDNs to DDoS protection or something like that, because BPF is usually popular because it has high performance. It is high performance systems, but is it possible to use this possibility in your solution to have something like DDoS protection, or then we are we don't need to use external providers for these kind of things?
I'm trying to make sure I understood you. Are you asking whether Cilium with eBPF can provide DDoS protection as well?
Yeah. Or maybe...
Or whether it's compatible with other solutions that use eBPF, exactly. Both questions. Yeah, so it is compatible. So in general, Cilium is compatible with other eBPF-based solutions. So let's say you're running Datadog with the eBPF probe, or you're running, let's say, Aqua solutions using eBPF, or Viz has just announced eBPF-based runtime agent. That is, in general, compatible. Sometimes it matters. You need to define the order which programs runs first. So they will all attach to similar hook points. So essentially, like, the order will matter. If the first component at the hook, let's say, drops the packet, then the second program in the chain will not see it, as an example. So there's this disordering problem that you have to take care of. From a DDoS protection, what Cilium can offer you is blocking IP ranges very effectively. It's doing this using XDP, so you can feed in a list of IPs, let's say a couple of 100,000 IP blocks that you don't want to receive from. This is something we can do very, very effectively. And we also have some capabilities to, for example, look for specific patterns in HTTP requests or like some other like well-defined static filtering that we can do. Cilium does not have, let's say, URL categorization or so like AI-based threat mitigation stuff that some of the vendors claim. It's like static, predefined configuration that you can feed in. But we do have some DDoS protection. I can send you the documentation to have a look. We also actually have good integration with, let's say, CDNs. And both on the ingress and egress path. So you can actually, for example, use Cilium to force traffic through an egress Cloudflare proxy. So if you, for example, want to make sure that all your traffic leaving a cluster or leaving infrastructure has to go through a Cloudflare proxy, Cilium can also take care of that as well. So we can definitely chat further if that is of interest.
Thank you so much, Thomas. Round of applause.
Thank you very much.